Hello, Algebra 2 Trig students. We are on Unit 5, Lesson 3, which is about solving logarithmic equations. We might do a little modeling at the end. Basically, we're going to use our previous lessons of those laws of logarithms, apply them here so that we can solve for x. Now, of course, our warm-ups are not using those laws, but it is reviewing a little bit of exponential or reviewing exponential and logarithmic forms and how they connect to each other. So you can pause here and try letter A. And then you might get stuck on letter B, but you can unpause and listen to how you should do it. So it says solve for the exact value of x in each equation, no approximations. So we don't want any decimal answers, we want an exact value. Well, letter A is in purely exponential form, so I already have 10 to the power of 3x minus 4. I can rewrite 1/10 as 10 to the power of -1. And then, of course, that would be taken to the power of x, as you see here. Now, because I have the same base, I can just set these exponents equal to each other. So I'm going to get 3x minus 4 equals, well, what's the rule that I do here with these exponents? I multiply, so 3x minus 4 equals -x. I can add x to both sides. To get 4x on the left-hand side, I can add 4 to both sides to get 4 on the right-hand side, and then when I divide by 4, I get a value of x equals to 1. Now, if you're not sure if this is going to work, because in the end, all of our solutions will not work today when we go through our lesson, so you should check it, right? You can eyeball it right here, plug in a 1, plug in a 1. If I plug in a 1, I would get 10 to the power of 3 minus 4, which is 10 to the -1, and that is equal to 1/10. So it is indeed correct. If you look at the second example, we have 3 to the power of x. I'm going to subtract 1 from both sides to get 3 to the power of x equals 4. Okay, you might be saying to yourself, oh, I'm stuck. I have no idea what to do. Well, remember, we're supposed to solve for x. X equals what? Well, you might be saying to yourself, oh, right, I remember. This is exponential form, b to the k equals n. I can rewrite that in logarithmic form by putting log base b of n equals k. So that is exactly what we are going to do, because as you can see, x is equivalent to our k, and we isolate k, or it's going to be x in this case, by rewriting exponential form into logarithmic form. So our base is 3, so I'm going to write log with a base of 3 because the base of the exponential is the same as the base of the log. Then I'm going to put whatever value I have here, which is my n that goes here with my log, so it's log base 3 of 4, and finally that is going to equal x. So I have isolated x. This is my final solution. If I wanted to solve for x, this is an exact value. I don't have an approximation, that's just the exact value. Now we will eventually get an approximation, a decimal answer when we use our calculators toward the end of this lesson and toward the end of the unit, but for now that is known as an exact value. Okay, we're moving on to solving logarithmic equations. We have two examples here. Now let's look at example 1. It says solve log base 5 of 3x plus 1 equals 2. Well, this is logarithmic form. If I want to solve for x, somehow I have to try to isolate x. Well, remember we just said that logarithmic form can be rewritten in exponential form or vice versa. So log base b of n equals k is the same as b to the power of k equal to n. So I'm going to go to that immediately. I see I have a 5 here, that's my base. So 5 to the power of 2 equals 3x plus 1. Now I have just a basic algebra problem. So 5 squared is 25 equals 3x plus 1. Subtract 1 from both sides, divide by 3, I get x equal to 8. So that is my solution. I can plug it in, make sure it works. Right, 3 times 8 is 24, 24 plus 1 is 25, and log base 5 of 25 is in fact 2. Okay, let's look at our second example here. It says log base 2 of x squared minus 15 equals log base 2 of 2x. Well, if they both are log base 2, then what do you think is true about the two numerical values that are right beside? Log base 2 of some number equals log base 2 of some number. Well, what do you think is true about these two numbers right here? Hopefully you're saying to yourself, oh, those two numbers must equal each other. Sorry, that's a little messy. So x squared minus 15 has to equal 2x. Now I move everything to the same side, and I set it equal to 0 because it's quadratic, right? So I get x squared minus 2x minus 15 equals 0. Now I need to factor and solve. So x minus 3 times x plus 5 is going to equal 0. That's how I factor. They add to give me negative 2, multiply to give me negative 15. And so my two solutions are 3 and negative 5. Now, if I plug in a 3, right? When I plug in a 3 up here, I get log base 2 of 9 minus 15 equals log base 2 of 2 times 3. Well, what's the problem here? 9 minus 15 is negative 6. Am I ever allowed to have a negative number here? No. Not only that, these don't equal each other. So this solution actually does not work. So you have to check your answers. The next one, if I do the other solution of negative 5, I'm going to do log base 2 of negative 5 squared minus 15, right? And then that should equal log base 2 of 2 times negative 5. Sorry, I'm running out of room here. That's messy. Apologies. Negative 5 squared. Negative 5 times negative 5 is positive 25. I get 25 minus 15, which is log base 2 of 10. But on the other side, I get 2 times negative 5, which is negative 10. Again, you cannot have a negative here. 10 and negative 10 don't equal each other anyway, so this solution also does not work. So in this case, even though you did all the math, and it looks like it has two solutions, neither solution work, so this actually does not have any answer. So there is no possible value for x, therefore this equation does not have a solution. We call these two results that you got, 3 and negative 5, extraneous solutions, right? And they have to be rejected. So usually we show rejection by just crossing them off. You could write the word reject if you want, but they do not work. So you need to indicate this, and you need to make sure you're checking when you're doing problems on your assessments and in your homework. All right, so let's talk about strategy. How do we know when to use what strategy? Well, here's a list of strategies for your solving, right? So we can say we might equate exponents if we rewrite it in exponential form. We might equate logarithms. We might convert from exponential form to log form or log form to exponential form. And we most certainly will probably have to use our laws of logs at some point to simplify before we solve. So don't forget, any of these solutions can have extraneous solutions. We do not want answers in decimals. We want to have everything in exact form. Exact form means you can't get decimal answers. Well, you're not going to have a calculator anyway, so you're not going to be able to get decimals. All right, so example A. It says log base 2 of x equals 2 times log base 2 of 3 plus log base 2 of 5. Well, why did we just do all those practice in the last lesson with laws of logarithms? That was so you could solve for x. So on this right-hand side of the equation, we're going to condense or compress this expression so that I can try to get a little bit simpler problem so I can solve for x. So my log base 2 of x is just going to stay the same. The right-hand side, I'm going to take this value right here, that's the power. I'm going to use the power rule, and I'm going to replace that onto my 3 and make it 3 squared. So that becomes log base 2 of 3 squared plus log base 2 of 5. Well, remember this plus sign right here. What does that allow us to do? That allows us to rewrite the right-hand side to multiply 3 squared. That's the product rule. We can multiply 3 squared times 5. My left-hand side just stays the same. There's nothing I'm going to do with that. It's just log base 2 of x. Well, now if we have an x, log base 2 and log base 2 are identical to each other, so that means my x must equal 3 squared times 5. So I'm just going to say x equals 3 squared times 5, or you might be saying that's just 45, Mrs. Leopold, come on. So x is going to equal 45. Now you might want to check it. If I plug in 45 for x, does log base 2 of 45 equal log base 2 of 3 squared? I moved the 2 up here, plus log base 2 of 5. And yes, given those properties or the laws of logarithms where I'm going to multiply 3 squared times 5 to get 45, yes, in fact, that is correct. Okay, letter B. Letter B, once again, I'm just going to give you the hint. Use your laws of logarithms to get yourself started. If you want to pause at any time, please, by all means, pause and try these on your own. Right? So letter B. I see this minus sign. I see I have a log base 2 and a log base 2, so I'm going to use my quotient rule. And my quotient rule says that if I have a minus sign, I'm going to take this x plus 3 that's in my numerator, whatever follows my denominator, or sorry, my minus sign is in the denominator. So this is what I end up having. Log base 2, now I can compress, and I get x plus 3 divided by x squared, and that equals 1. Now I'm stuck. Well, I am in logarithmic form, so let's look over here at this list. Can I equate exponents? No, there's no exponential form here. Can I equate logarithms? No, there's no log something equals some log. Can I convert to log form? No, it's in log form. Can I convert to exponential form? Yes, I can convert to exponential form. This is logarithmic form, so log base b of n equals k. I'm going to convert that to b to the power of k equals n. So my b is 2, so 2 to the power of 1. Excuse me, I'm going to go ahead and color coordinate that. So 2 to the power of 1 equals x plus 3 divided by x squared. So now I have 2 equals x plus 3 over x squared. So remember, this 2 is just the same as 2 over 1. Maybe that's going to help. I'm showing you that so you know you can cross multiply. So I'm going to get 2 times x squared equals 1 times x plus 3. So once again, I'm going to have a quadratic. This is 2x squared. So I'm going to move the x to the other side by making it minus x, move the 3 to the other side by making it minus 3. Now I'm going to have to factor and solve. So you can pause here, do your own method of factoring. I know I have to have a 2x and an x to get 2x squared. My only two numbers that can multiply to give me 3 are negative 3 and 1, or negative 1 and 3. I put the negative 3 here because I would get negative 3x. This would produce positive 2x, which would give me that negative x in the middle. And so this is how you would factor. Again, you should have your own style of factoring. Don't rely on me. I'm doing this as mental math. From here, I get my solutions. My solutions are positive 3/2 or negative 1. Now, are both of these solutions going to work? We don't know. We need to check it. So when you plug in positive 3/2, am I going to get any negative number in either of these locations? No. 3/2 plus 3 is 4.5. 3/2 squared is a positive number, so it should work, but you can do the math to check it. The second one, I take the negative 1, I plug it in here. Negative 1 plus 3 is positive 2. So that should work, right? So I get log base 2 of 2, and then I get minus log base 2. Well, negative 1 squared is just positive 1. So log base 2 of 2 minus log base 2 of 1 is just log base 2 of 2 divided by 1. And yes, that does indeed work, and it equals 1. So both of these solutions work. Even if it's negative, we have a negative 1, but it actually works because when I plug it in to either location, those are positive numbers right there. So it works. My third example, letter C. We have a log on the left-hand side and a log on the right-hand side. So when I see, a log plus a log minus a log, I'm immediately thinking of those laws of logarithms and how to condense it into one single logarithmic statement or expression. So I have a log base 7. I can see log base 7, log base 7, log base 7. Any number, these two numbers. And so what follows, I divide by what follows the minus sign, and so I'm going to divide by 3. Now that equals log base 7 of 12. So again, because these two logs are both the same, log base 7, then I'm going to equate my logarithms, which means I can equate x squared divided by 3 equal to 12. Those two numbers must equal each other. So x squared divided by 3 must equal 12, and therefore x squared equals 36. So when I take the square root of both sides, remember that you must have two solutions. So x is going to equal plus and minus 6. Now, if x equals 6 and negative 6, then negative 6 does not work because you would get a negative 6 here, and you're not allowed to have a negative number there. But we want to see that you understand when you take the square root of something that you get two solutions, right? If I had x squared equals 36, I could also make that x squared minus 36 equals 0. And when I factor that, I would get minus 6 plus 6. It's the difference of squares. So I have two solutions. We want to see that you understand that there are two solutions. And then we want to see that you understand that we reject one of those solutions. So the answer here is only x equals 6. For our last solving, again, it's very similar. It looks like we're going to use our laws of logarithms on each side so that we can convert to log form and equate our logarithms. So we're going to use our laws of logs so we can equate our logarithms. So I would pause and try this on your own. All right, did you get x equal to 17? If you did, you got the answer correct. If you didn't, you probably want to pause and look through this work, or I'll try to explain it really quickly. But here we had log base 2's. I have a minus sign, so I'm going to divide 2x minus 1 divided by x plus 5 to get this statement here. Then I have to take my 1/2, that's the power rule. I need to take the 2. I need to put these on these numbers, so I get 36 to the 1/2 divided by 2 squared. It's divided because of the minus sign, so that's the quotient rule mixed with the power rule. Then 36 to the 1/2 is equal to square root of 36. 2 squared is equal to 4. But the square root of 36 is 6. Keep the 4. And 6/4 is the same as 3/2. I'm reducing it to the smallest numbers just to make my life easier later when I'm actually solving. So instead of putting 6/4 down here, I put 3/2. Now I need to cross multiply, right? So I could set those equal to each other because this log base 2 and this log base 2 are the same, right? So now I just know these two are equivalent, which is what I did here. So I multiply 2 times 2x minus 1 and x plus 5 times 3. Distribute. And when I distribute, I combine my like terms, solve for x. I get x equal to 17. If you plug it in, it would indeed work. It is not an extraneous solution. It's a working solution. You can check it just to make sure, but it does work. All right, modeling with logarithms. This is just a basic problem trying to show you that we can get an answer, how we would use logarithms in a problem. It says the pH value for a substance measures how acidic or alkaline the substance is. Pure water has a pH of 7. The formula for pH is pH equals negative log of H plus, where H plus represents the hydrogen ion concentration in moles per liter. So this is a non-calculator question. It says if lemon juice has a hydrogen ion concentration of 10 to the negative 2.3 power moles per liter, what is the pH? So pH equals negative log of H plus. Well, what is H plus? H plus is the ion concentration. Well, what is the ion concentration? They said that would be 10 to the negative 2.3. All right, so I substitute in, right, my H plus is this number here, so I replace 10 to the negative 2.3 with the positive ion, hydrogen ion. So now I need to simplify this. So how do I simplify? Well, the power rule says I'm going to take this number, negative 2.3, and I'm going to put it in front. And so when I do that, I would get, a negative, and then negative 2.3 times log of 10. Now, if there is no base right here, that's the common logarithm, so we're just going to put in a 10. And what is log of 10? Log base 10 of 10? Hopefully you're saying to yourself, that's just 1. And so my pH is equal to negative 2.3 times 1. Well, double negative is just positive 2.3. So what is my pH level? It is 2.3. Okay, letter B, it says if the pH of a substance is 12.35, so this time we gave you the pH, what is the concentration of hydrogen ions? So that would equal negative log of H plus. So I need to find the concentration of the hydrogen ions. So what do? Well, this is logarithmic form. I need to change logarithmic form into exponential form. So remember, if there is no base on the log, it's the common law, so it's the base of 10. So 10 to the power of 12.35. Oops. Pause a minute here, Mrs. Leopold. I have an issue. My bad. We have to deal with this negative first. I can't have a negative and do what I was just doing. So I have to divide each side by negative 1 first and rewrite it. So I get negative 12.35 equals log base 10 of my H. Now I can do the exponential form. So 10 to the power of negative 12.35 is my hydrogen ion concentration. So there I have it. All right, change of base rule. We're going to use our change of base rule just to show you an algebraic way of solving a question as our very last problem here. You might use your change of base rule, you might not. It just depends on what kind of style, how you like to approach the word problems, and how you use your calculator. You can use a graph, or you can solve things algebraically. The problem is this. When you're in press to test mode, you cannot, okay, let me go back. If you're in regular mode, if you're not in press to test mode, then you can actually, and you have a TI Inspire calculator, you can just punch this into your calculator. It allows you to put in the 3, it allows you to put in the 7, and it gives you the actual answer. But when you're in press to test mode, you can only work in the common log with log base 10. You may not believe me, but it's true. So if you can only work with the log base 10, then you're going to need to know how to use the change of base rule if you want to solve things algebraically. And so the change of base rule says that we need to take log base b of m. That's going to equal log base 10 of m divided by log base 10 of b. Right? So over here, if I look at my example, I gave log base 3 of 7. That would just be log of 7 divided by log of 3. Now, when you're not in press to test mode, you can check this, get a decimal answer, press this into your calculator, get a decimal answer, and see if they are equal to each other, and they should be equal to each other. So I'm going to let you pause. I'm going to let you plug this into your calculator, and then you can unpause and check your answers here with me momentarily. Okay, so what should you have gotten? You should have gotten 3.170, or it was 0.169925. So if you were confused, you could have just left it as 0.1699 or 0.169. That's fine, but rounding it correctly would have been 0.170 because we're rounding to 3 decimal places. This one rounded correctly was 2.069, or you could have had this answer here. Here we had 2.861, and letter D was 2.044. Again, we had to do the rounding. And finally, we are doing our last question, which is something we did in our exponentials, except now we're going to show you the algebraic solution. You were doing graphical solution. Now you can do an algebraic solution if you find that easier. Some people find that easier, so we'll go ahead and show you the algebraic expression. So it says, or algebraic equation, sorry. It says, upon graduating from college, Ashley took a job with a starting salary of $40,000. She can expect a 6% raise in pay each year. How long will it take for Ashley to earn $60,000 per year? So you might remember that equation we had, which was taking whatever your starting amount was and then adding 1 plus the rate and taking that to the n power. So she ended with $60,000 per year. That was her final amount. She started with $40,000 per year. She got a 6% raise per year. So it's 1 plus 0.06 because we change our percentage to a decimal. So we move it twice to the left. And then we want to know, how long will it take? Well, this, I shouldn't have put a t, or shouldn't have put an n. That was really a t. That's the amount of time. So we're trying to solve for t, which is an exponent. So now we can use logarithms to help us if we want. So if I took my 60,000 here and I did it algebraically, the first thing I would do is divide each side by 40,000. So those cancel. Divide 60,000 by 40,000. So I end up with 3/2 equals. Now, the other thing I'm going to do is I'm going to simplify. What is 1 plus 0.06? Well, hopefully you're just saying to yourself, that's 1.06. So now I have 3/2 equals 1.06 to the t power. Now this is exponential form, and I have my variable here as an exponent. So I could rewrite this in logarithmic form. Remember, b to the power of k equals n, therefore log base b of n equals k. So I'm going to take log of my base. My base is this decimal number of 1.06. That's okay. We can have a decimal base. Then what do I put next to it? Well, that's where my 3/2 or 1.5 goes. And then what is that going to equal? Well, that allows me to isolate my exponent. So that equals t. So I cannot plug this into my calculator if I were in press to test mode. Instead, I would have to use the change of base formula. So I'm going to change that into log 3/2 divided by log of 1.06. And so the base there is 10. So I plug that into my calculator, which I'm going to do right now. And I get the time is approximately 6.9585 years. So approximately 7 years is when it'll take Ashley to make $60,000 per year. It'll take her approximately 7 years, or 6.959. If we were rounding to 3 decimal places, then this would be her answer. So graphically, how could we do it? Well, you could take your same equation and you are going to take the left-hand side and put that into the function 1. And you can take your right-hand side and put that into the function 2. And you can sketch a graph to show where they intersect each other, right? So this, I'll do that in the other color. Sorry. So this would be your exponential growth. It's going to start at 40,000 and continue to grow, and then you're going to have an equation at 60,000 and see where it intersects. And this point of intersection, because this is your time across the x-axis and across your y-axis, is the amount of money that you have. So when you find this point of intersection, it should intersect at after 6.9585 years. All right. Hopefully that's good. We're going to do more calculator problems, more word problems as the unit progresses. If you have any questions, make sure you go ask your teacher. Bye.